I will try to describe a 4-bit universal shift register. So let's say these are inputs, these are outputs, and two more pin here, shift right and shift left, and two control inputs. So these are the inputs D2, D1, D0, while Q3, Q2, Q1, Q0. Let's call these X1, X0, shift left serial and shift right serial. So the control bits decide that what operation will the register do. So let's say this one. When these are 0, the register will hold the output data, so these 4 bits will not change, so we can call it hold. When it's 0, 1, shift, just arbitrarily defining shift, let's say shift right will happen. That means whatever is here, so this one will go to here, Q3 will go to Q2, Q2 will go to Q1, and Q1 will go to Q0. Q0 will be lost. And similarly, when this is 1, 0, shift left will happen. So yeah, let's call that shift right and shift left. So when shift left is happening, shift left, this input, this is coming to, let's use another color, so this will come here, Q SLSCR, whatever is here as input will travel to the Q0, Q0 will go to Q1, Q1 will go to Q2, Q2 will go to Q3, and Q3 will be lost. So, and when this 1, 1 here, that means these 4 bits will be loaded. These are input bits, whatever data, 4-bit data will be loaded to the output of the register. So let's call it load. So these are the operations, and we can show some demonstration. So let's say Q3, Q2, Q1, Q0, and this is shift right, shift left, and here we have X0, X1, X0, and let's say initially it's 0, 0, then 0, 1, 0, 1, 0, 1, 0, 1. So this, and then maybe 1, 0, 1, 0, 1, 0, afterwards 1, 1. So let's start with 1, 0, 0, 0, and let's say we have maybe 1 here and 1 here. So when 0, 0, it's staying like that, it's not changing. When 0, 1, it is shift right operation. So of course this one will come here, so this one will be 1, this one is coming here, this one will be 1, this one will be 0, this one will be 0, and this one will be lost. So one shift right operation, another one, so again 1, 1, 1, 0 will happen. With the third one, 1, 1, 1, 1 will happen. With the fourth one, essentially it will stay like that, because this one is going there, this one is going there, this one is going there, and this one is coming here. Essentially nothing is changing. So for this state, what will happen is shift left. So we have, we have 0, let's say we have 0 here, so that we have some interesting result. So these are not changing because these are just the inputs. So when it's 1, 0, the shift left operation started to happen. So this will be coming here, this one will go here, this one will go here, this one, so it will be of course 1, like that. Another shift left will be 0, 0, so the 0 will be pushed from the left, and it will keep going to the left, and the 1 will be pushed out. This is staying there. So again, so 1, 1, and with the third operation what will happen, 0, 0, 0, and 1. And of course with the fourth one it will be loaded, so we haven't said what is there, so let's call this is like that. So these are the input bits, and when the x1, x0 are 0, 0, whatever is here will be loaded, so it will become 0011 because this is just loaded to the output, so it's loading new data. So that's what it is, that's how it will operate. And also, as we saw, this last bit for shift right operation, this bit is getting lost. For shift left, this one, the whatever, this one is getting lost, so that can be avoided by having a loop connection. So if for shift left this is connected back to here, here, what will happen, the shift left serial, this input will keep changing because this one is coming back here, so a loop operation can be made. Similarly for the shift right, uh, maybe this one can be connected back here. So these are just to make a loop operation so that the last bit is not getting lost, it's coming back, and of course that way this one and this one will keep changing, it's not the fixed one. So yeah, that's a possibility. So anyway, I will try to write this operation, describe this function in a Opal Junior program, so that we can think of how to program a GAL to uh, do this function, or to program a GAL device for this operation.